it is actually it is kind of similar problem, but in this case we need to calculate the fan power. So that's the new thing. Otherwise, rest of the thing should be same. So you just try to understand the problem. It is quite easy. A house built, it should be on a reverse. Okay, forget it. If a house built on a riverside is to be cooled in summer by utilizing the cool water of the river. It's 15-meter long pipe. So that means the length from here to here, this is 15 meter. Okay, the duct diameter is 20 centimeter. So the diameter, this is 20 centimeter. It passes through the water, so that means it is actually kind of inside the water like this. Air flows through the underwater section of the duct at 3 meters per second. So this is how the air is flowing. And the temperature is 15 degrees centigrade. The fan efficiency, you see, the fan efficiency is given 62%. So this is the fan efficiency. We need to calculate the fan power. What actually we need to overcome the frictions, the resistance. So when the flow will go through this pipe, it will experience some sort of resistance. So now the fan efficiency is 60%. So what amount of power you need to overcome the resistance of the fan? Okay, so what we'll do here, guys, we'll start solving this problem. So this is also not that hard. Let's say, let me just write it down. We know from the lecture that the this power actually we need, it is the formula is the volume flow rate delta P over the efficiency of the fan. So this is actually the electric power we need. So this is the volume flow rate, this is delta P, and this is the efficiency. So we need delta P. That means the same thing like what we did for previous problem. Delta P means we need F, because delta P it is FL over D rho V square over 2. So that means we need F. We need epsilon over D. We need Reynolds number. We need then we need the volume flow rate. So that's the overall procedure here for this problem, guys. So in that way we can calculate this volume flow rate. We can calculate this delta P. Eta is given. So then we'll substitute all the values. So we know the velocity. So how we can calculate the volume flow rate from the velocity? It is actually the velocity into the cross-sectional area. Volume flow rate is velocity and the cross-sectional area. So it is velocity is 3 meters per second. Area is pi d square over 4. So this is 3 pi. Diameter is 20 centimeters, so 0.2 square meter square over 4. So we'll get the volume flow rate is 0.0924. It is meter cube per second. So this is the volume flow rate. So just take this first one. Now let's calculate the Reynolds number. The Reynolds number, it is equal density, velocity, diameter, viscosity. In this problem, guys, it is 15 degrees centigrade temperature. At 15 degrees centigrade temperature, so we'll get the properties here. Actually, at 15 degrees and when air is at 1 atmospheric pressure and 15 degrees centigrade temperature, the density rho, it will be 1.225 kg meter cube. Okay, and the viscosity, it will be 1.802 and 10 to the power minus 5 kg per meter second. So this is the values you can get from the tables. from your book. You already know the appendix. I already uploaded the appendix, you know. So yeah, I'm not actually showing the tables today because you already know how to get these values from the tables. Now substitute the value here. So if we substitute the values, so the Reynolds number, rho v d mu. Rho is 1.225, velocity is 3, diameter is 0.2, and the viscosity is 1.802 and 10 to the power minus 5. So the Reynolds number, it will be 4.079 and 10 to the power 4. So which means this is the flow is turbulent. Flow is turbulent. Now the question is, guys, if this flow is laminar, so turbulent flow means now we'll calculate the roughness factor. But if the flow is, because our ultimate target is we actually want to get the value a friction factor value. But if the flow is laminar, then do we need this roughness factor? When the flow is laminar, let's say we calculated this value and we found it is less than 2300, that means laminar flow. So then do we need the roughness value? No, because we can simply use the formula like the Reynolds number is, the friction factor, it is 64 over Re. This formula, it is for a laminar flow. So yeah, so check carefully. So that's why we need to check the Reynolds number carefully, okay? So I've got it is here. Now epsilon over D. What is epsilon over D? In this problem, you look, what is the materials? The materials we have, it is stainless steel. So epsilon value, it is 2 into 10 to the power negative 6, and the diameter is 0.2 millimeter. So it will be 1 into 10 to the power minus 5, the epsilon over D value. If you ask me how you got this, you just need to go to the previous slides, and I've already uploaded in my lecture slide. I got all the slides from my lecture, so you will get everything from the lecture, the epsilon value for different commercial pipe materials. So now use the Colebrook equations. So the Colebrook equations is F negative 2 log epsilon over D 3.7 plus 2.5 on and Reynolds number into F. So now you just substitute all the values. It is 1 over F negative 2 log epsilon over D means 1 into 10 to the power minus 5 over 3.7 plus 2.5 on over Reynolds number is 4.079 10 to the power 4 into square root of F, and the so if we simplify this, F equal, we'll get 0.02195. Okay, one important announcement. You'll see the final exam is MCQ. That means you need to select the correct answer. I can tell you, there should be answer for all problems, but you will also get some options like none of those. That's actually, yeah, we put some options, but for each and every problem, if you calculate correctly, you will get the correct value. So the only thing could make some differences is the gravity value. So maybe used it is 9.81, maybe in the exam you're using 9.8. So check this, okay? If you find slight deviations from your calculations and the given answer, that means it will be the closest one, okay? And sometimes it could be due to some outstanding digits. You may get some slight deviations. So you must need to select the closest one. Just double check that your calculation is correct and then go through and then select the answers. Okay. All right, guys. So we got F. Now calculate delta P. We have done. Delta P, the head loss is F, L over D, rho V square over 2. So F is 0.02195, length 15, diameter 0.2, density is 1.225, velocity is 3 square over 2. So we need to convert the units here to get the Pascal. Same thing on kg meter per second square, and 1 Pascal, we know 1 Newton per meter square. So we'll get it is 9.07 Pascal. This is delta P, and now we know the power. It is equal the volume flow rate, the pressure loss over the efficiency. So the volume flow rate we got earlier 0.0942 meter cube per second. Delta P is 9.07 Pascal. Eta is 62%. So you can say 62 over 100, or you can say 0.62. It's the same thing. So we'll get it is 1.4 watt. So this is the power we need to overcome the resistance of the pipe.